Hello, PreCalc. I promised today that I would finish the review tonight, and it turns out there are 4 problems that we didn't get to. So let me move quickly through those and you'll be in ship shape for the test tomorrow. So on the first one, I'm going to give you a right triangle. Jot these down in your comp book where you were doing the bingo. And let's say that that side is 5 and the hypotenuse is 20. And let's say we're looking at this angle right here. Alright, so the question is, find the value of angle of theta. Find theta. And we'll do 2 decimal points for that. So to do that, we're going to use one of our trig functions, and side theta is known. We could use Pythagorean and come up with this one, but we can avoid that by picking the trig function opposite over hypotenuse, and that is the sine function. So sine of the function equals 5 over 20. So that is 5 over 20. Putting it into my calculator. 0.25, I knew that. So we have sine of an angle is 0.25. So the calculator knows where to get that answer out of your calculator. It is not taking the sine of 0.25, it's saying the sine of the angle is 0.25. So that is called an inverse sine function. So I'm going to do sine inverse of 0.25. And that is on the calculator. It's going to be second function sine inverse 0.25, and that is 14.48. So over here we see 14.48 is the degrees and that this answer is. So that's 1 down, 3 to go. So this was, I don't know what number we were up to in class, but anyway, you can number it accordingly. The next one, number 1 for tonight. Number 2, you can just add it to your review and use the actual number. All right, let's do another one like that. And we have a right triangle. This is 9. This is 29 degrees. And this time we want to find this side. Find the length of side C. So the trig function from the position of this angle, this is side opposite, we don't know it, so we don't want to use sine, but we do know side adjacent and we know side hypotenuse, or we know it's involved. We have to have that involved because that's what we're looking for. So I'm going to use cosine of 29 equals adjacent over hypotenuse, because cosine of an angle is adjacent over hypotenuse. Alright, spend some time memorizing these if you haven't already. So, cosine of 29, I'm going to calculate that all at the end. I want C by, that's 9 divided by C. I want C by itself. Multiply both sides by C and divide by cosine of 29. If you've already changed cosine of 29 to a decimal, you'll be dividing by that. I saved it to the end, so when I did 9 divided by cosine of 29, I got 10.29. Alright, that's the length of C. There were no units given, so alright. There's going to be a trig problem, something like your trig projects, which we have put on hold till test is over. And that is where we have some scenario, and it's going to use a trig triangle like that, and we're going to put it all together and solve the problem. For example, suppose there's a ladder leaning against a wall, and the ladder one end is on the ground here. One is against the wall. So we have the wall, then we have the ground. And the ladder is leaning in between. Let's say I can measure the angle that the ground makes with the ladder to be 25 degrees. And I know that the base of the ladder is 6 feet from the wall. So my question is, how long is the ladder? Alright, so from the position of this angle, I'm going to need to know the trig function that uses this value and this one. Once again, it's cosine. Cosine of theta equals adjacent 6 over hypotenuse L. Except I put cosine of theta, I know the angle, so it's cosine of 25. Solve that for L, multiply both sides by L, and divide by cosine of 25. It will get you this. And that is 6.6 foot ladder. A 6 foot ladder you've heard of? Well, this is a 6.6 foot ladder. Alright, so that's the third. The last one for tonight will remind you how to take values that are in angular velocity and change them to angular to linear and linear to angular. I can get this out. Let's say that you have something that's spinning in 5 revolutions in, say, 1 second. So do you know how to take that value, 5 revolutions per second, and put it in another form, another angular velocity, in radians per second? So we'll try that first. So how do you get from revolutions per second to radians per second? Well, we're going to have to use a unit multiplier that gets rid of revolutions. So revolutions is going to be on the bottom. And 1 revolution, 1 all the way around circle, is 2 pi radians. So we end up with 5 times 2 pi, and that is 10 pi. And we are in radians per second. So how would you go from radians per second to inches per second? So we're going to do 10, we'll start with the 10 pi radians per second. And seconds is fine, so I want to get rid of radians. A little trick to our problem is we have to be given the radians. So I'm just doing an example I'm making up. So this thing is going around 5 revolutions in a second, quite quick, and we'll say that its radius is 7 millimeters. It's very small. So 7 millimeters. So at this point I need that information because 1 radian or 1 radius, they are interchangeable, is 7 millimeters. So radians is gone, and sorry, we're not going to do it in inches per second. We're going to do it in millimeters per second. And so I get 7 times 10 pi, or 70 pi millimeters per second. All right, so we did quite a bit of that on our trig whip project, so hopefully it remains in your brain. All right, your brain has been trained to take this test tomorrow, so Mighty 5, I want you to study. You got some formulas to know. Here's a recap of ones I think of right off the bat. Arc length is theta r if you're working in radians. The area of a sector is 1/2 theta r squared where you're working in radians. We need to know sine is opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent, and the flip of those. Cosecant would be hypotenuse over opposite, secant would be opposite hypotenuse over adjacent, and cotangent would be opposite adjacent over opposite. Let me write that out. So this one is opposite over hypotenuse. This one's adjacent over hypotenuse. This one is opposite over adjacent. These are the flip. So we're going to have hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite. Okay. Also, what else do we have to commit to memory? I'm not coming up with a whole lot of other formula types that we have to memorize. Are you? All right, well, before the test starts tomorrow in the morning, bring up to mind any other things that we should have memorized. Oh, I know, of course, the unit circle. So the unit circle, I'm not going all the way around, but we know we go over the short, over the long and up the short. That's square root of 3 is the long guy. The short guy is 1/2. And that flip-flops when we go over to not, this is 30, or pi over 6. This is pi over 3. This is 1/2 square root of 3 over 2. And then in between is the pi over 4, which is square root of 2 over 2, and square root of 2 over 2. And that will take you all the way around the circle, alternating positions and signs, S-I-G-N's. Remember, the sine is the second coordinate, the sine of the angle, and the cosine is the first coordinate. And recall that the second divided by the first is how you find the tangent of an angle. All right. Special right triangles, you know the special numbers across from the 45 is the 1 square root of 2, and the special right triangle, the 30, 60, 90, is across from the 30 is the 1, 2 for the hypotenuse, and across from the 60 is the square root of 3. All right. I would like you to study and do me proud, Mighty Five, till we meet tomorrow at test time. All right, over and out. Enjoy your evening.